So we have an alcohol on one end and a carbon-carbon triple bond on the other, and we're asked one, two, three. Is that right? 1, 2, 3, oh, 4. Nope. And we're asked to make this thing, okay? Do I have that right? 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay, good. Okay. So all we're asked to do here is add 2 carbons and go from a triple bond to a double bond in the trans position. So what do we have to do? Well, we did see that we can remove this proton and make the acetylide anion and react that with an alkyl bromide like ethyl bromide and add 2 carbons. Then we have a triple bond and we just have to reduce that triple bond to a double bond. There's a problem, however. The problem is we can't pull that proton off. We need a strong base. The pKa for this as an acid is around 25. The pKa for this as an acid is around 16, maybe 17, okay? So if we try to just throw a base in here, we're gonna remove that proton and nothing's gonna happen. So we protect that alcohol. And that's where we use the TBDMS chloride. That's this thing. And those of you online watching this video now, you'll have to look at your solutions. But we just protect that alcohol, okay? So I'm just gonna say we protect it. We protect the alcohol. Now we use a strong base, and what strong base did Dr. Jha use? He used NaNH2, okay? So NaNH2, Na plus, NH2 minus, that's just gonna pull this thing off, make my anion. And then we use ethyl bromide. And that anion is going to do an SN2 displacement, and we're going to end up with this thing. There we go. Now, we deprotect it by using, so this is plus, this is minus the fluoride. Silicon loves fluoride. So when we protect this thing by making a silyl ether, when we throw the fluoride in there, it just goes and bangs the silicon, knocks off the alcohol, and we get the alcohol back. We deprotect. This is just a deprotection. And when we deprotect it, we end up with our alcohol. And we've installed that ethyl group, okay? And then all we have to do is use Ligler's catalyst. And it works because it's going to put 2 hydrogens on the same side and give us the cis double bond, okay? So in this particular reaction, the way we need to look at it is look and see if there's something that looks like your molecule to begin with, and that looks a lot like it. We've lost a double bond and we've added some carbons. So then we got to figure out, well, how am I going to add a carbon here? I've got a handle, but I have to be careful and I have to protect this, because if I try to remove that proton, any base is just going to remove those protons. So we protect it with our TBDS, our silyl chloride. We make a silyl protecting group, and then we can remove this proton. We can form a carbon-carbon bond with that acetylide anion. We saw the acetylide anion, I don't know if you guys saw it in 2533, but we did see it in this chapter when we talked about addition to carbonyls. When we started forming carbon-carbon bonds, one of the things we do is we make an acetylide anion, and then we add it to a carbonyl group to make the alcohol, is the example in the textbook. Okay? So when we do these retrosynthetic analyses,